Hello and welcome. In today's class, we'll be discussing about the insertion sort, which is a part of ISC Computer Science Class 12 syllabus. So, insertion sort is also a sorting technique, just like bubble sort, selection sort. But the method of sorting is a little different. So, let's try to understand how insertion sort works. So the basic idea behind insertion sort is to divide the list into two regions, sorted region and unsorted region. And each time we are picking element from the unsorted region and putting it in the sorted region such that the sorted region always remains sorted. And we keep repeating this process until the entire array is sorted. Obviously, this will be more clear to us with the help of an example. So let's take one example. So here is an example. We have 5 elements and we want to arrange them in ascending order using the insertion sort technique. So we start insertion sort with the second element, not with the first element, but with the second element. So the second element in our case is 14. So we pick 14. As we pick 14, we assume that the elements on the left of 14 are sorted. Elements on the right of 14 are unsorted. So when we pick 14, we want to put 14 in the right place on the left side. So what do? We compare 14 with 25. Or we can say 14 is compared with the elements towards the left of 14. So 14 is compared with 25 and we see that they are not in order. 25 should be after 14, not before 14. And that's why we interchange their positions and now we have this arrangement. 14 has come to the left of 25. And now we can say that this region, the region on the left side is sorted while the region on the right side is still unsorted. So from the unsorted region, we pick 19 now. And now 19 is compared with the elements present before it. So firstly, 19 is compared with 25 and we realize that 19 should be placed on the left of 25 because 19 is less than 25. And then 19 is compared with 14 also. But when we compare with 14, we see that, okay, 14 is less than 19, so we don't need to go any further. We should put 19 in between 14 and 25. And that's why 25 should be shifted to the right so that we get the space for 19 to put here. So when we do that, this is the new arrangement. 19 has been placed between 14 and 25. Now, these are the 3 sorted elements, whereas 8 and 10 are unsorted. So we pick 8 from the unsorted region and now we compare it with 25. It should be present on the left. 8 should be present on the left of 25. When we compare it with 19, 8 should be present on the left of 19. And when we compare 8 with 14, so 8 should be present on the left of 14. So for that, each and every element on the left are shifted to the right by 1 step. So 25 comes here. That means 25 goes to 8's place. 19 goes to 25's place. 14 goes to 19's place. And then 8 is placed over here. And when we do that, this is our new arrangement. Now only 10 is left. And when we compare 10 with 25, we realize that 10 should be on the left of 25. When we compare with 19, 10 should be on the left of 19. When we compare with 14, it should be on the left of 14. But when we compare with 8, 10 should be on the right of 8. So we stop there because now we know that all the elements after 14 are less than 10. So we don't need to go any further. So we stop here and we try to put 10 in 14's place. But before that, we need to make space over here. That's why 25 is shifted to the right, 19 is shifted to the right, 14 is shifted to the right, and then 10 is placed here. And when we do that, this is the new arrangement. And now we can see that the entire list or the entire array has been sorted in ascending order. So this is the concept. And when we talk about performance, the performance is slow, just like bubble sort, selection sort. This algorithm is also slow because its time complexity is big O of n squared. So that's the concept of insertion sort. Next, we will look at how we can write a Java program to implement insertion sort. Let's write a program. So I've created a file insertion sort.java. Let's start with the import statement. Then we create the class. The main function. And we create scanner object for user input. Now let's ask the user how many elements the user wants to work with. So we give the message n is equal to, where n is the number of elements. Now once we know the number of elements, we can create an array of that size. So we can write int a if we are working with integers equals new int n. The next step would be to ask the user to fill up this array with integers. So we give a heading message, enter n elements. And we run a loop for this. So a of I equals integer.parseInt int dot next line. Now the insertion sort begins. So for that, we will run the loop with I starting from 1 because we want to start from the second element, not from the first element, like I explained in the example. So I should not be 0, I should be 1, and I less than a dot length, I plus plus, and we take a variable key as a of I. The ith element is picked up, which needs to be put in the right place. And this value we are calling it as key. So next, we want to compare it with all the values before it. So that's why j is another index and it should always be 1 less than I. That's why I minus 1. So if I is 1, j will be 0. If I is 2, j will be 1. Because the key has to be compared with all the elements present before it. That's why j is starting from 1 less than the index of I. Now, while j is greater than equal to 0, because j is also an index, it cannot be less than 0. And key is less than the jth element. We keep shifting the elements to the right. as long as the element that you have picked, as long as it is less than the element on the left, and as long as the value of j is greater than or equal to 0, we keep shifting elements on the left to the right by one step. So that's why a j plus 1 equals a of j. So the jth element is being placed in j plus 1th position, and j minus minus, j keeps decreasing. And once this inner loop ends, a of j plus 1 equals key. We put the key in the right place. And that's all in the insertion sort. And now we just have to print the sorted list. So we give another message, sorted list. So for I equals 0 less than a dot length I plus plus, a of I with a blank space, and our program is complete. Let's check the output. So as you can see, firstly it is asking for the number of elements. Let's say I want to work with 5 elements. And now it is asking me to enter the 5 elements. So let's enter 20, 45, 12, 19, 4. And you can see the sorted list. It is arranged in ascending order. If you want to do the sorting in descending order, all you need to do is just change this less than sign to greater than sign. That's all. Let's check. So if I change it to greater than sign and I compile and execute the program, let's say 92, 45, 78, 12, 18. So now you can see all the elements are arranged in descending order. So that's all in this video. I hope you have understood how the insertion sort works. Thank you so much for watching. See you in the next class.